All right, let's have a look at the tension design and the timber member. I think tension design is quite straightforward. By looking at the equations, you just need to factor in K1 factor, K4 factor, K1 and K4, and you can find it given in section 2, 603. So consider your load duration factor and your K4. The only thing is that you got to make sure that you still consider K24 factor, that is the size factor. So for LVL, if I were using Carter's LVH high span, which means you would just use their factored specified a K24 factor, that is 150 divided by D, that powers of 0.167. That would be your size reduction factor for your LVL. You might have different size factor for different manufacturer, so check on that. For glulands, you can go for just go by standard K24, that is 300 divided by D. If you're using the section that is less than 300 deep, then you don't need to factor any size factor. So that'll be 1. So yeah, so I think tension design is straightforward. The other thing is when you have a member loaded in tension and you have a bolt that is embedded in the tension member, just be careful that you would use your net tension area rather than using gross area. And this A here, we're talking about a gross area of the tension member. But if you have a bolt coming through, then they would just deduct the area of the holes, and you would get your net cross section of the timber. It would be something like that. So that would be your net cross section of the timber. So it's slightly reduced. So that's the you wouldn't normally do that when you do your detailed European unit model UIM, and you check in different affiliate modes, and you would use your net tension to check your tension braces, for example. Yep, so that's the design intention. That's quite straightforward. Thanks for watching.